Now, we've been talking about secondary and tertiary reactions, again, because these carbocations are stable enough for these reactions to occur. Generally, pure methyl groups, those are carbons with all hydrogens around them, or primary carbocations are off limits. And that's because they're just too unstable to exist under the conditions of this SN1 type of substitution reaction. But they do react to form alkyl halides. So how do methyl and primary alcohols react to form alkyl halides? They actually react through a different mechanism. And again, we're going to go into detail about this mechanism in chapter 6. But generally, in an SN2 mechanism, the first step is still protonation, as we showed in an SN1. However, when we lose water and add our halide, this occurs in a concerted manner in the second step. So this is all one step. Both the water leaves and the bromide enters at the same time. Because this slow step in which we have the leaving of water and the addition of bromide has two molecules at the carbocation, it is called a bimolecular step. Thus, this reaction is called substitution nucleophilic bimolecular. Now, it's very clear to say before that, even though in a SN1, this water can kind of get in the way, it is fully left. It is fully detached before our bromine enters. In an SN2, these are both happening at the same time. Water is leaving, bromine is attaching at the same time. This is the difference in an SN2 reaction. And another note on this is the reason that primary alcohols can go through an SN2 reaction is because their carbocation does not have to be left out and unstabilized, because this portion of the reaction in which we have a carbocation is all in one. So we never have a full-blown carbocation. There's never a point in an SN2 reaction in which we have this with the full charge on it. Instead, we have this point in a transition in which you have water and bromine reacting at the same time. And because we don't have to have a carbocation, which would be very unstable for primary, this type of reaction can proceed this way. Now, there are other methods to forming alkyl halides. Again, they're very important synthetic precursors, and sometimes they're just interesting in their own right. And because a stereochemical course of reacting alcohol plus a acid halide, because that can be unpredictable, because we can get different types of stereocenters, we can have inversions, we can have mixtures of stereocenters where we go from R, but we make R and S. Generally, because this can be unpredictable, we can use other methods to make it a little more predictable. Also, many functional groups are not stable in concentrated acid. When we're starting with hydrogen chloride or hydrogen bromide, if we have any other thing attached to our starting material, if we're not just starting with a pure hydrocarbon, then these concentrated acids can wreak havoc. They can do other reactions as well as just this SN1 reaction. So sometimes milder conditions are needed. So there are other methods of taking an alcohol and an acid halide and turning them into this hydroxyl group for a good leaving group. One of those is through the cyanochloride reaction. So here we have cyanochloride. It reacts with an alcohol to give an alkyl chloride. So the chlorine here is coming from the cyanochloride instead of from an acid chloride. So instead of from HCl, which can be very strong, we're using cyanochloride. So an amine can be used in this sense as a Bronsted base catalyst to help this reaction go along. So the amine being used here is a triethylamine. You also sometimes can see other amines here. This is a catalyst. Remember, catalysts do not actually participate as a reactant or a product. They just help the reaction to go faster. They lower that energy barrier of the reaction. For this type of reaction, using cyanochloride, you still get a similar type of product, right? You still make your alkyl halide, substituting our OH for Cl. However, the inversion is the typical result. So instead of having a mixture, inversion is generally the typical result for a cyanochloride reaction. The intermediate here, instead of water that leaves, we're not making water and then having water leave, is a alkyl chloral sulfite. This is the intermediate. We form this on our oxygen that was our alcohol. This is a good leaving group, just like water can leave relatively well. And because it's pretty bulky, you have the inversion occur because the attack of our chlorine will happen from the bottom. So you can see again, we have inversion of our stereocenter. We form, instead of water, we form this SO2. And also there's excess chlorine ion left over because we did not react both of these chlorines. One of them was displaced for the original bond to form. Now note, we're using a different amine as a catalyst. This is pyrimidine. This is also an amine, it has a nitrogen group on it. This is just a catalyst. So you can also see pyrimidine used to catalyze this reaction. Another version of this reaction uses phosphorus trihalide. The halide on it could be bromine, chlorine, iodine, etc. Generally, we're going to look at phosphorus tribromide or phosphorus trichloride. And these can react with alcohol to give, again, alkyl halides. And this is predominantly with, again, inversion of configuration. So it's similar to our cyanochloride we just looked at, where you invert the configuration. Here's some examples of that phosphorus tribromide reacting with different alcohols. Here, this is a carbon attached to one other carbon. So this is actually a primary alcohol. And this is a carbon attached to two other carbons. So this is a secondary. You can use phosphorus trihalide for primary, secondary, or tertiary alcohols to form your product alkyl halide. You'll notice that, again, this will occur with a predominant inversion. So if you're starting with a R, you would end predominantly with an S, or vice versa. Okay, so that is the end of our chapter 5. Again, just focus on the introduction of the idea of a mechanism and energy diagrams, what you're likely to see, how these alcohols can react to form alkyl bromides, and again, the general idea of an SN1 reaction carbocation stability and how it affects an SN1 reaction. But we're going to dive even more into the substitution reactions. I'm going to talk to you more about SN1 and SN2 reactions in chapter 6.